welcome to Desk of Ladyada.
Hey everybody, and welcome to another Desk of Ladyada. We're here again Saturday night. We're going to be doing another one of our Maker I/O Circuit Playground videos. So strap in, get ready for part 3 of a 10-part series.
That's right.
This one is called Concept.
Yeah. So we started off with Concept. Ladyada. What did you talk about in the Concept series? The very first one.
Just the concept, right? Sorry, the first one we did was Concept. That one was where we talked about the idea of what we're going to build, and so we had an hour and a ish video long about why I was building Circuit Playground, the point of having a low-cost circuit board for education, and who it's for, and what my end goal is with it. So you can watch that video.
Okay, so that was number 1, episode 1, and then after that we had research.
Right. So the second one is research. And
that was last week.
That was last week. And research is where I looked at what's available on the market and what other people were doing and kind of trying to see like where this would fit in the ecosystem of existing products. If you're designing your own product, chances are you're not the first one to try to solve whatever problem you're solving or design the product that does what you're looking to build. Just because you're not first to market doesn't really mean much. You can still have the best product or something that has a really good market fit. So research is where you kind of canvas what's out there and get a lot of information, kind of get all that information in preparation for part 3. And
tonight is evaluation.
Evaluation, that is tonight's.
Yeah. So with evaluation, because all of these videos are connected, if you haven't, press pause. Go watch the other 2. Are you back? Great. So tonight, evaluation, before you spend a lot of time designing your product, it's essential that you give it careful evaluation. First, weigh the pros and cons of your project. Begin thinking about possible team members. Test your technology and establish a realistic timeline. Everything check out? You're ready to design. So what are we going to talk about with evaluation in context of Circuit Playground tonight?
Okay, so this is kind of sorry. What's the fourth one? Because I don't remember.
I have it all handy.
Yeah, if you have the fourth
next one,
the fourth one is going to be
prototyping,
the next one?
Right? Oh no, the next one's going to be design.
Design, right. So evaluation is after you figured out what's on the market, where you fit. That's the research phase. And before you actually go and do the design, this is kind of where you want to kind of get your ducks in a row. Like figure out what direction you're going to take based on your research. What have you learned and how you're going to use that. And this is actually where I start doing the rough sketch. Before I do the design, I have to spec out parts and I have to decide what am I going to include, what am I not going to include. This is actually the beginning of, and I made a note of this is where you're going to start having to fight that old dragon, engineering paralysis, right? So engineering paralysis is what happens when engineers have to make decisions. And engineers can be very bad at making decisions because
Is that why we get eval boards that do everything? Because they're like, well, it has a buzzer. Well, it has every sensor. And then it's like a size of like a pizza box. And it costs $200.
It's a little bit, but it's more also. I mean, yes, there is the okay, we'll just throw in everything. The clown car issue. Yeah. But it's also Bluetooth or Wi-Fi, and then you kind of get stuck, and you end up not doing you don't make your decisions at the evaluation step, and that's fine. You can push some decisions down, but if you don't make core decisions now, you end up your paths start forking, and so you have to have 15 prototypes, and you can waste a lot of time. So if you make decisions now, it saves you a lot of time later.
Okay, so measure twice, cut once type thing, right?
Yeah.
Okay. So what are you gonna? And when you say sketch, you actually don't mean on a piece of paper. You actually mean let's do
Some people do.
Part research.
Some people sketch on a piece of paper.
Yeah.
I don't because, I do a little bit, but usually on little notepads. Like I said, it's funny. There's people who have Kickstarters or Indiegogos or whatever, and they always have these architectural drawings of here's what we designed. And I'm you didn't really do that. You always work from the design from manufacturer a little bit. You don't, form and function, it's actually, this is one of the things that...
well, you sit a few feet away from the means of production, so I don't think you celebrate or heroize, going to your mood room and coming up with
Yeah.
like a clay sculpture.
You have to be
You
careful.
actually start designing it kind of from manufacturing from the start.
Right, because I'm an engineer, so I design for manufacturing, but that, because I'm coming in from from function.
Yeah.
One of the things, one of the few things I learned at MIT is I took a couple classes with Professor Maida, who's kind of his whole thing is simplicity. And actually, he has like two things that he taught me. One, make sure there's an on-off switch, and then for portable things. And second, because a lot of like engineers like leave it off, and it's actually one of the decisions I made for this. And then second, it isn't about the digression between form and function. You have to have both. Right, it's not like, oh, should it be like form or should it be function? Because that's kind of what a lot of people end up doing. It's like either it's going to be beautiful or it's going to be really functional. But it's like he's like, oh no, you have to have both. So how can we combine both into this design? Make it do what it's supposed to do. Make it manufacturable. Make it fit the price. Like you have to do all of these things. You can't just pick two. You actually kind of have to pick all. I mean, there's trade-offs on that way, but you have to have it do all things.
Okay.
Yeah,
so
engineering's fun.
Let's get into eval. So what's first?
Okay, so the first thing is that I'm going to go back to the document we made in the last one, and I'm going to just quickly just kind of like breeze through it. So this is that document. So we ended up kind of making a couple requirements as we wrote this out. We basically went through what's out there on the market. And, some have microcontrollers and potentiometers and sound sensors and light sensors. And some have piezos and slide pots and, alligator grids and LEDs and all that good stuff. And we kind of went through that. And as we did it, we kind of came up with some things that we really, really liked and some things that we really don't like. So, we didn't want to make it breadboardable. But we did like having, alligator clips. And we want to make sure that there's some sort of like audio input or output. I want it to be able to work with at least one of Arduino, Scratch, Blockly, Minecraft as a possible pairing of the technology. I wanted to have at least 3 sensors. I was okay with having some of the things that it do be like mediocre. Like it doesn't have to be the highest quality temperature sensor, the highest quality like audiophile microphone. It just has to be good enough for the kind of projects that students would be doing in school. And from looking at from looking at the research and also just seeing what a lot of kids are building in their schools, I mean a lot of it is like very, there's a lot of science projects where it's like you get some magnet wire and an LED and a nail and like a 9-volt battery and it's like make a motor. Like it's very simple stuff. It doesn't have to be technologically advanced as long as it gets the idea across. But I didn't want the cost to be $25 or less. You can always have a bonus pack of, like super pack where it has all the extra things, but I think just to get started, wanted to hit that $25 price. Sometimes you have to work from price backwards. And in this case, because of that, I'm setting that up as sort of the first requirement. And as we go through the evaluation of what components to add, I'm going to work back from that. Sometimes you have to have a functionality be your minimum. And if you have a certain functionality, like, okay, it has to be a 4K display. I mean, for whatever reason, you determine that is the absolute number one requirement. Then, when you're pricing out your device or your electronic components, if you've decided like I have to use this processor, I have to use this display, I have to use this sensor, then you might not be able to work back from price. It's these are one of those things. Like sometimes it's cost sensitive, sometimes it isn't. If you're making like luxury goods, you're not as cost sensitive. In this case, I'm working on educational electronics that's supposed to be very simple and the goal of it is simplicity, cohesiveness, and price. So I have to work back from price. But I would like to have these minimal things. So that's good. And can you grab some of the photos that I sent? And I'll point them out. And then I'll also go to Adafruit as I do it. And okay, so we're going to let's get my browser ready, and I'll call on those photos later. So okay, we did this decision of the price, and like I said, the price comes first. So now we're actually going to do a rough pricing analysis for what I can do to make this stuff all fit into the cost. Like I've got a bucket and it's $25 large, and it's kind of like, what can I toss into that bucket to make it work out? So let's open a spreadsheet. You don't have to use a spreadsheet. If it's simple, it's okay. But let's pick out the first most important question. So the first question that you got to pick out is, what is your core microcontroller platform, microprocessor platform? You don't have to stick with the one you start with, but it will take you a very long time to get used to whatever microcontroller, microprocessor you're using. So if you can pick that ahead of time, that's a really good idea. So, I looked at, during the research phase, I looked at some boards. Some boards had Bluetooth. So that would be probably I would use a Nordic 51822 because it's a chip I know a lot. So we can look that up. So let's see, okay, what does it take to add a Nordic 51822? So this is a Bluetooth microcontroller that's a Cortex M0 with BLE built into it. And there's also some chips from TI and CSR, but this is the chipset I know best. So this is where, you can just start getting an idea. Okay, so this chip is, $2, basically, looks like.
Yes, that's if you're going for a $20 price point, you have to start thinking about it.
You have to start thinking about
what 10% of my cost right now.
That's 10%. Now, I will say one thing, especially, we'll cover this also a little bit later, but when you're speccing out parts, the list cost is sometimes negotiable. And if you have relationships with people at the company, say you promise to promote, especially if you're doing open source hardware and your hardware is going to be used as a demonstration of their technology, sometimes you can sort of sweet talk them into hey, can you give me a 30% discount on these chips in exchange for me writing tutorials or supporting you? Yeah. And it's hard to do this when you start, but as you develop more products or your product becomes more popular, you'll find you have a little bit more negotiating space for it. It's very hard if you're just starting out, but you never know. And also, use your social networks. If you have a friend who works at Atmel or works at TI, if you're an engineer, and chances are if you're working on designing your own products, maybe you have some engineering background. Who did you go to school with? Did any of them work at these companies? You can use those social connections to get you to a friend who Analog Devices and can help you. Maybe use some of their marketing budget to help you promote your product. These are all things we'll talk about also later, but it's something to keep in mind if there's some pricing that you're I really want to use this part, but the retail price is just too high. Use your footwork to work on that.
Yeah, and one thing I thought I'd mention that might be helpful, because I usually get on the legal and contract side of things, is that when you want certain parts to evaluate, sometimes you're forced or asked to sign a non-disclosure agreement. There's bidirectional ones, so in other words, they can't talk about what you're doing, you can't talk about what they're doing, but these are templated and no one's looked at these for years. So one of the suggestions that I always make to others, and this is what I ask the chip companies usually, is, okay, your non-disclosure agreement says 5 years. So everything's going to be different in 5 years. Can we make it a realistic time frame? Because sometimes you are forced, they will not talk to you, they will not do things unless you have a bidirectional NDA in place. So what I've proposed often is, can we make it 3 months? And if there's pushback, it's we're going to be releasing this in 3 months.
Yeah.
So we're going to be doing something in 3 months, and then you can start at 3 months and then wiggle around, and eventually what I found is 6 months is kind of the common thing now that they're all willing to do.
Yeah, you can. As you, for example, CSR. I mentioned them because they also have a Bluetooth chip. Yeah. So we've used the CSR chipset, and we have the CSR development platform. To even get started with CSR, you have to basically give them a couple $1,000s, and you have to sign an NDA, and everything is under NDA, and they're very strict about it. You can find pirated versions of the development, but you don't have a license for it, and it's a bad idea. If you're going to use a chip, you should definitely get it officialized, because you don't want to have to deal with that later. You think about it in the long term. But CSR requires very strict NDAs. Nordic has very lightweight licensing agreements. It's not a big deal. It's not open source, but like you kind of have to sign a document just saying like, hey, I'm going to use this code. If I use your code, I'm not going to try to reverse engineer it or manipulate it. And then I think TI has also a license, but it's very similar to Nordic. So, it's not going to be like completely under NDA. There's levels, right? Like with Nordic, you'll be able to actually get a real data sheet. Like if I click this, I will get a true data sheet. Let's find out.
Yeah.
This is the eval sheet, but there is a data sheet available.
And one thing that I've learned is having the lawyers at these companies discuss a time period that makes sense is easier than specific clauses for a bidirectional NDA, because they're just like, because what you get in a conversation about is like, what, you don't believe the pace of technology is happening faster than in 5 years?
Redline it.
Yeah, well, I'm usually like, I just have one edit. Can we make the NDA for 3 months? Because we release on average a product a day.
Yeah.
So anyways,
okay, so for example, like here, you can get the full data sheet for this chip, which actually is quite promising. If you can't get a data sheet for the chip you want to use, you might find it difficult to work with it, because it's almost certainly under NDA. Companies that require NDAs are usually used to working with very large companies that you might not be able to get the attention you need. Working with companies that have open source tool chains means that there might be more of a community. So this is something to think about when you're deciding your chipset. So we'll decide maybe NRF 51822, and we can put in cost, but I'm actually going to call this budgetary.
Okay.
Just kind of a little bit of it's a word people use. It means like not really the cost, but it's kind of the cost.
Okay.
And
it's like what you want to spend.
It's kind of what you want to spend. So actually, I have because I buy a lot from Digi-Key, I get a price of $1.71. It's like, it's not so bad.
Okay.
So
are you logged into the site right now?
I am. I'm logged in.
Okay, so you're logged into the site right now, and your account allows you to see
I get special pricing because I buy a lot.
Okay. All right.
And we negotiated. Anyway,
and that's visible on the website.
And only visible to me.
Only visible to you. Okay.
So people watching this, you know that you can get this chip for $171. You can email Digi-Key and be like, hey, I know it's available. That's another thing. Work with your distributor. Your distributor can give you a sales rep that might be able to negotiate your price down.
Yeah, and like we buy a lot.
We buy a lot. We buy a lot of chips. And another thing is, if you're buying a lot, you can say, look, I'm going to buy a lot, and the distributor doesn't necessarily eat the price. They actually go back to the manufacturer of the chip, and they give them a discount. You have to arrange it, but the industry is a little bit old. There's a lot of, it isn't like Amazon where you like click and buy and it's like, well, whatever the price is on the site is what it is. I mean, there is negotiations that can be made.
Can I give one more pro tip?
Go pro tip.
Because I'm usually on the contract negotiation side. So here's one, but try to bring it up.
Yeah.
So a lot of companies are trying to get into the maker market, and they're spending tons of marketing dollars. And generally speaking, a lot of the marketing dollars go to waste. So flying 5 dudes out to some conference in Europe is super expensive because these dudes love eating steaks and stuff. And what you could do sometimes, and this is just an idea, have a site that you have a story that you're telling, do videos. Suggest that part of the Marcom budget, marketing communication budget, subsidize the first 1,000 chips for you. So they can help tell the story of this chip and why it's important and all these different things. Because the cost per acquisition for customers is usually higher than just giving you some chips. And I see the marketers kind of circling around, like, how do we get people to use chips? And meanwhile, there's a lot of people who just want to lower their BOM, their bill of materials. You should be able to apply that marketing budget that usually is waste. 99% of it, of marketing, is waste. You just don't know what 99%, which part of it is. And so I think that's something to suggest because I'm seeing more interest in that idea.
There's also, if you're a maker, this is maker to market, you go to maker fairs. If you go to the large maker fairs, like Maker Faire Bay Area in New York and also Europe, there will be chip manufacturer representatives there. Atmel has a booth, sometimes TI has a booth. And if you go there, they'll be showing off the chips that they want to promote, the MSP 430 or the NRF 51822 or TI will be they're pushing their chips. Everyone's got an 8-bit chip, everyone's got a 16-bit chip or 32-bit chip. Everyone's pushing their Cortex, equivalent. And when you're there, you're there, and there's going to be salespeople there. That's a great time to talk to them and say, "Hey, I want to use your chip." And here's actually a pro tip. I really want to use your chip, but TI offered me $1.50. I really want to use your chip because I really like your architecture. So can you match their price?
Yeah, and do you have a real quote from both?
Yeah, no, I mean
parties.
Go and say or you can even use the Digi-Key quote. Say, hey, I go on Digi-Key, and I really want to use your chip, and this is what I like about it. And be very specific about. Don't make up stuff. No, I really like the compiler that you use. I really like the open source libraries that you guys provide, but I really am stuck with the price. I need to match this price. Can you match this price? And there's often salespeople there who will actually be able to get you started on getting that pricing. And you're right there in front of them, and they're there to sell. So it's like if the leads are good.
One last question about this. So on the website on Digi-Key, it says, this part can be programmed by Digi-Key. For details, please contact our custom department, and they have an 800 number. So is that something that people should consider when they're evaluating a chip, if the distributor can program it for them?
I'll say something. If you're just starting, I wouldn't do it because you're going to be making a lot of variations to your firmware. This is something that you might want to look at when you're in large production. But when we go over the test procedure...
After developer edition is out.
Yeah, get it after the developer edition. But it's something to think about. If it is a service that's offered, you usually pay depending on the chip, 25 to 50 cents, $1 per chip. Okay, so here's an Atmega 328P. So if we want it to be Arduino compatible, this is the chip we'll use. And it's interesting, it's not that much less expensive than the Nordic. I don't get special pricing on this, for example. So this is the Atmega 328P. However, if I use either of these chips, they don't have a USB to serial converter on them. So I need to use a USB to serial converter to get USB, which is one of my requirements that I did during research. Must have USB. And I could use a BitBang USB, but I want this to be easy to use. And BitBang USB is it's fun, but it has issues with USB 3 ports, and it can be hairy, and I want to have debugging. And for other reasons that will be discussed later, I want to have USB. So you'll also need a USB to UART converter chip. A couple ways you can do it. You can use a chip that, especially, or you can use a USB microcontroller and have a sub microcontroller. So for example, the microbit uses an NRF51822, and then it uses an embed, so LPC11U24 or something to act as the embed interface, which also does USB to serial. So what I like to do is, I'm just budgetary, take the unit price and click up to give you the pricing available. Now, some things are not in stock, they're non-stock, but they're still, okay, this is possibly available for about $1.30. Looks like the Scilabs chips and also the FTDI chips are about $1.40. So let me see. I don't think I've got any. Looks like they have
the Digi-Key
similar. Oh, they have a similar part for $1.50. Basically $1.50.
The Digi-Key folks are known for being around 24/7, all year. At some point during one of our broadcasts, we should call them up and say hello.
Oh yeah, we should do that.
Yeah, we'll do that.
Okay, so USB to serial is going to be about $1.50. I actually kind of know that you might be able to get this to about $1 by using a USB microcontroller and programming it. And there's other chips available. For example, you could use a low cost CH430 chip, which is I think 50 cents. There's other chips around that you can use, but I'm going to say I think I can get this for a little bit less. So I'm going to basically say $1. Because again, I could use this low-cost version chip, or I could use an official chip, or I might be able to get better pricing or so. So basically, this is what I'm looking at if I wanted to use Bluetooth or Arduino compatible. And then there's another option, which is I can use an Atmega 32U4. And this is also an Arduino compatible chip because, again, I kind of want it to be Arduino compatible. So the Atmega 32U4 has USB built in, so I don't need that extra chip, which is kind of sweet, but it's a little bit more expensive. So this chip is about $350 instead of a lower cost for each one. So there's a Mega 32U4, and this is about $350, which is of course a little bit more than these two, but has the benefit of it can act as a USB keyboard or mouse. So trade-offs that need to be made. There's also a couple other chips that are Arduino compatible that I did think about briefly, like for example the AT-SAMD series from Atmel also. And this also has USB. There's a huge family of them. And I want one that has at least 64K. They have multiple variations on size. So like this one, and this was actually kind of interesting. They're much less expensive than the the Atmega 32U4. So it's kind of, this is something that I find interesting. Just to make it easier to compare pricing, I will do only the tape and reel. That way I can just look at the ones available in the group and then sort by price. So you can kind of tell that like these are less expensive than the 8-bit, which is weird. It's like it's a 32-bit core, but it's less expensive. When I was first playing this out, this core was a little bit new, but it's still worth putting down here. So an AT-SAMD, and again, you can pick all sorts of different number of pins and how much RAM and how much flash. But you basically want at least 64K of flash. Looks like it's about like $1.75. Okay, so we had multiple brunches where we talked about which chipset to go with. And I actually ended up also adding ESP8266 as a possible core. So that is a module that we have available. So ESP80. And you buy these direct from Espressive. And so we get these modules, I think, for about like $3 or something. So this is $3. The problem is you also need one of these USB to serial converters. So it ends up being about $4. But you get Wi-Fi. And I was actually thinking about Wi-Fi, and I'll tell you why I ended up not going with Wi-Fi, because I had to make a quick decision. So the problem is a lot of schools have enterprise Wi-Fi. So even if you have a device with Wi-Fi, it doesn't have the authentication capability to get onto the network.
Yeah.
And so like I was like, oh, that's just
a story about that. I forgot. It was like there was a bunch of devices, but they couldn't get on the school.
This happens all the time, and
Yeah.
I see this in the forums, and this is why we have like a community forum. When we sell a lot of products that have like the ESP8266, but a lot of students struggle with it because they're like, well, I'm in school and I can't get access to the network through my device because the administrator not locked it down. So it's like, I really want to have Wi-Fi, but like it's just like not. It's just not something that.
So this is where you got to make decisions.
Yeah, these are
Who's it for?
decisions. So I'm like, okay, maybe later.
So you're evaluating your choices.
Yeah, I'm evaluating my choices. So like, I'm just because Wi-Fi would be really cool. Like, I do IoT stuff. I could do like wearable, whatever. And it's Arduino compatible also. But unfortunately, the enterprise thing. And also, I was like, there's another issue, which is if you're using wireless, you have to get FC certification. And the Nordic is like not really Arduino compat. I mean, it kind of is, but like not really. And because it has this soft device, it makes some things very difficult. Like you can't control NeoPixels from it. With these, you'd have to have a subprocessor. So I actually kind of ended up deciding I really wanted to make sure it was Arduino compatible. And the Wi-Fi was cool, but it was significantly expensive because you need this and you also need a USB to serial converter. The NR51A22 was really, really cool, but it was something that I thought maybe I'll do later as an add-on or something, because programming it natively was not as easy. So I basically then had a choice. Okay, I could use the Atmega plus the 328 plus USB to serial converter chip. I could use the Atmega 32U4, or I could use the AT-SAMD. And I was actually like really heading towards the AT-SAMD, even though it's a very new chip. And then kind of at the last moment, I ended up contacting some people from Atmel and saying, hey, like I'm about to, make this circuit playground thing. And I was kind of choosing between the 32U4 and the AT-SAMD. And I said, I really like the 32U4 because even though it's a slower, older processor, this is a 8 megahertz, 3.3 volt 32K, flash, and then 2K RAM. Even though this is an older processor, it was slower and it was not as impressive as this like 48 megahertz, 32-bit, 128K of flash, and then 32K of RAM. Even though this chip had more technical functionality, there was a lot more example code that would work with this one. So this is the evaluation. I wasn't, and this is like part of the engineer paralysis. I was like, should I do the SMD? It's a really cool chip. But I was like, you know what? It's too new. The Arduino support's still kind of not 100%. It's such a different processor core that I was concerned that a lot of existing Arduino examples wouldn't work with it. I wanted to take advantage of this ecosystem of Arduino. And so I ended up contacting Atmel and saying, hey, could you guys basically give me the Atmega 32 at half price? Could you just kind of do that? And they're like, yeah, absolutely. So they ended up giving it to me for $1.75. And so then I was like, well, you know what? I'm going to make version 1.
Yeah.
Use this.
So I guess it's in the chip maker's interest if they want to see a chip used in a really big release like Circuit Playground to make sure it's Arduino compatible.
I was kind of pushing on the hey, Arduino compatible, and they're like, well, they were kind of like, well, the AtSMD is really cool too, and I said, it is really cool, and I said, how about I make version 2, and when I get to version 2, I'll update it to the AtSMD, and that's something you can do. Like when you're struck with engineering paralysis, because I was kind of paralyzed for 3 weeks, juggling which chipset should I go with.
Yeah.
There are also other chipsets that we kind of sort of discussed that aren't even on this list. It's like, well, I could go with a PIC. Why not? Or I could go with, an MSP 430 maybe. I could go with an STM32. STM32 would be a half the price of any of these, but it would be a lot more challenging to make it Arduino compatible. It wasn't a chip I was necessarily familiar with. I think I would definitely be able to get it do what I wanted. But there were a lot of other things in the way that made it less happy for me to use.
Okay. Well, I've got a question for you. Since
yes.
We're in the eval part, and you have this on a spreadsheet, and we talked about it briefly. So in your dream scenario, what price would you want wireless to be part of the future version of Circuit Playground? Where and what and who? And how much? What would be ideal?
Well, I think here's what I actually ended up thinking of as a, because I was thinking about this deeply, because I was like, well, I really wanted to have a Circuit Playground that had, Wi-Fi or Bluetooth, and it's like, well, I could have an add-on. You have a Shields for Arduino, why not just have a $10 add-on for Circuit Playground that lets you add Wi-Fi? You can do it for $10.
Designing a whole new board.
Because, you just have this as a subboard, and you'd kind of plug it on as a shield. If I can get the ESP8266 for $3, or the individual chip for $1, the module, and it plugs on top for $10. That way you can still maintain your original pricing.
Okay. Are you leaning towards ESP8266 for?
I think as an add-on, yeah. And maybe by the time we finish these videos, I'll have a sketch of what it would be. It'd be like a board that you can basically plug in. I mean, you can use alligator clips anyways.
7 more weeks.
Yeah. So, for example, we have the Flora. Flora doesn't have Bluetooth, but we have a little BLE add-on.
Yeah.
So it's like even though Flora is not a Bluetooth processor, you can have accessories.
Yeah, if you buy 50 of them, you're down $12.
Yeah.
Sorry, no, $10.
Yeah.
Woo. Okay.
That's the reseller.
All right.
I'm logged in. But so these are things you can think about. Like, okay, well, can it be an accessory?
Yeah.
Like you were talking about your camera. It's like the camera doesn't come with every lens. So sometimes it's like you can't make a lens that does everything, but you can have a fairly good lens that you come with, and then you change it. Okay, so that's the chipset.
Right.
So let's rename this sheet chipset. And you can of course adapt this as later, but I really did want to have something that was Arduino compatible. And the chip, the Atmega 32U4, it's an old chip. It doesn't have the new hotness. It doesn't do DMA. It doesn't do everything, but it does do what it does fairly well. There's a lot of example code. We have example code for it to do MIDI. We have example code for it to do mass storage. We have example code for it to do keyboard, mouse, joystick, USB serial. All that stuff is really well established. And sometimes going with something well established is what you should do for your first version. And then you can always get a little experimental in the second version. The first version of your product should be very reliable. So reliability is a little bit more important than maybe the most, and in my opinion, than going crazy with excessiveness.
I feel like I feel like for this particular product, if the first 15 minutes of it are precious.
Yeah.
So when the students and just about anyone gets it out of the box, if it doesn't just work, then this could be potentially their first experience with electronics. So if we don't make it great, then this could potentially turn them off from doing electronics for a really long time.
Yep.
So yeah, I agree.
Okay, so here's where you do the rough, like, okay, I have to work back from the final price. So we decided the chip. Chip is going to be $1.75. Great. So the total so far for the bill of materials. And then you want to find out your two margins, and depending on where you're selling and what you're doing, you might need different margins. I usually start with about 40% because for the stuff that I sell and the places that we sell from, tend to want about a 40% margin. So this is the wholesale price.
Okay, so let me, because there's a couple questions that I'll do on real time.
Yes.
So just to be clear, the question is, so you as a company want to sell something with a 40% margin when you sell it to resellers.
Yes.
So then they could also sell it for 40% margin.
Right. You buy a gallon of milk for $5, whatever. Let's just say $5. The store you bought it from buys it from the farm for $2.50. And then it costs $1 to make that gallon of milk, right? Everybody has a cut. And so if you're going to sell this only on your own, through like a Tindy or your own like PayPal button, whatever, you don't have to have nearly as much margin, but your distribution is very limited. It's very hard to do international. It's hard to ship to a lot of places.
Yeah. Okay, so two things. I drink almond milk too.
Almond milk then.
Yeah. The other one is, so I have no idea what that other milk thing is like.
Moo.
But the other thing is, you're exactly right. The thing that we've seen, because we get emails and more, there's people who have no margins. So they therefore can't have resellers.
They come to me and they're like, we really want Adafruit to carry this. And I'm like, great. And they're like, my widget is $50. I'm selling it on my site for $50. And I said, okay, well, how much does it cost for us to buy it? And they say, well, $47. And I'm like, okay, so by the time I pay for shipping and if there's any returns, I've lost money. You're selling it to me for $3 less than you're selling it.
They should have had a higher price point or
worked on the bill of materials.
Worked on
the valuation.
Okay, that was one of the questions that came up. Thank you.
Yeah, this is only, of course, right now we only have one component in our budgeting, which is kind of minimal, but we're starting somewhere. And then the final price. And then you can, noodle around these numbers, but to get 40% margin, you multiply by 1.66, and I'll explain how you do that. So margin is the percentage off the final price. So if you have something that costs $10 and it has a 40% margin, you multiply it by 0.6 because it's 1 minus the margin. Like 40% off of the retail price is the wholesale price. That's a 40% margin. Margin is calculated from the final thing, not multiplied from the base price. It goes backwards. So to get that number back, you have to multiply by about 1.66 to get up. So it's a 66% markup is equivalent to a 40% margin. So inverse of the fraction. So that's why we multiply up. So right now, there's absolutely no way for us to really charge less than $5 for this thing. So that's kind of a good thing that we know. I mean, unless we want to have zero margin. And you can manipulate your margins around as necessary. Like if you want a 30% margin, maybe, and you might decide like, hey, this is a product that maybe is extremely expensive. Extremely expensive items can have lower margins because, you can't make 10 cents on a $1 sale, but it's sometimes okay to make $100 and $1,000 sale because it's like, well, it's $100 is still worth the effort. Sometimes not just percentages. There's a whole industry based on how to price things. Okay, the other thing we definitely need is the printed circuit board. And you can go online and basically figure out like how much is PCB. You can quote PCBs. If you have a rough idea of how big it is, can you go to the overhead real fast because I'll show what we're basing this off of. Since I'm kind of basing the circuit playground off of the Flora, I know it's going to be a little bit like this but bigger. As we go into prototyping, you'll figure out the exact size of it. It just so happens I know that because I've been manufacturing Floras for a while, that a PCB this size is about 75 cents in quantity. Not the first 2 or 3, the first 2 or 3 are going to cost you $10 a piece. Once you get to the order of buying about 1,000 or 2,000 or 10,000 at a time, the cost is about 75 cents. So you can quote PCBs.
I had an idea, Ladyada.
Yeah.
Can I show it off?
Yeah, sure.
So if we do really advanced stuff one day, with Circuit Playground, all sorts of different permutations. So this is the latest issue of 2600. I used to write for it, but I thought it'd be neat to maybe consider a
phone,
a rotary phona. But a lot of people, a lot of kids don't know what a rotary phone is, but a lot of adults who are the instructors might. And I thought that might be neat one day to do some type of rotary project with a maybe Circuit Playground phone edition, so kids could make a wearable cell phone watch.
Sure.
So anyways.
Sure, we can have a phone to plug on.
Anyways, live ideas. So this, by the way, this is where ideas come from.
Sure, there could be a cellular add-on. We could get, phone module we could plug on top. And you could have cellular. Okay, so back to Compy. All right, so PCB 75 cents. So you can see this is starting to creep up. Bill of materials already $2.50. Yeah, I know. It goes fast. And
expensive.
It's now $7 is the minimal price. Okay, so now we have the chip and we have the PCB. Well, we need a couple other things that are absolutely required. You need to have a micro USB connector. So let's go back to Digi-Key and search.
That was one of the questions, Ladyada.
What?
Why did you go with a micro USB?
Micro USB.
Did you evaluate others?
I did. Well, we have had products with mini USB. Actually, this old Flora has a mini USB. You want to go quickly? This is a very old one.
This old Flora.
This is a very old. This is like a prototype Flora. This is a mini USB connector, and
we found this in a cave.
It was not in a cave. It was not hiding in a cave. You can tell it's old because it's like this new one has large holes, and also has the older crystal. We moved to ceramic resonator, and the mini USB is really good. But at this point, when we designed it, mini USB was a solid contender for like the most popular USB connector. At this point, absolutely micro USB has completely won out. Every single device uses micro USB, except for like devices, which use Lightning or whatever connectors.
Another question.
Micro USB, yeah.
This was from the chats. So Adafruit micro USBs seem to be sturdier than other ones on other electronics. I'm summarizing. Why is that?
You have to pick the right package. So this is part of experience. I know that if you want to use a micro USB, you want to have one that's 50/50 SMT and through hole, which we'll look up when we look this up.
Okay.
So we're here on the Compy. So for connectors, I'll be honest, you can prototype with like buying parts from Digi-Key, but for connectors, I often go to 4UCon to get like large quantities of connectors. It's just that's where I go to get large quantities. Oh, sorry. But you can get a rough idea of connector pricing. Also, something you can go to the connector companies directly. So for micro USB, we want to have. Oh, hold on. No, that's not what I wanted. This is just the plug. Hold on. Micro USB micro B. And I think this doesn't seem right. Let's see if this. Oh yeah, now I clicked on the right thing. This gives you a sense about how much you're paying. So this is an SMT only one. So you can see how the pads that come out they're not through hole style. They're like sit flat on the PCB. You actually can get, if you have an enclosure or you have like really huge pads and vias and stuff, you can actually get pretty good mechanical reliability. But I find that people will rip them off. Still, these are basically 20 cents. And then this is one you can see how this is 50/50 through hole SMT. There's 4 through hole legs, and then the connector pads are SMT. You can actually pick and place this. Something to consider. You can use through hole components are often less expensive. Sometimes, connectors especially can often be less expensive if they're through hole, but it is a more expensive assembly step, and so the cost you're paying to do the assembly might overwhelm the discount that you get. So this part basically is the same thing, so about 20 cents. So micro USB, about 20 cents. Okay, so that's like just the minimal. And then, there's also going to be, I'm going to put down passives. And I give myself 50 cents for passives. This includes, just like indicator, LEDs, caps, resistors. It depends. I just know that it's approximately that much for, until you know design, you don't know exactly how many resistors and capacitors. But I know that I'm not going to have too many components, so I'm going to just basically budget as 50 cents. So already we're up to about half of our budget.
All right. Oof.
Half our budget. Okay, so that's the micro USB. And now I want to add some of the components. So, when we went through the research, we decided that we wanted to have sensors. And so since I've already blown half my budget, I'm like, okay, I can't add a really cool 9DOF sensor because those chips are just going to blow through my budget. I need something that is inexpensive, the least expensive as possible. And just from experience, I know that some inexpensive sensors are temperature sensors and light sensors. Light sensors, temperature sensors are super cheap. If you're doing temperature sensing, you're typing temperature sensor. Oh, and as you're speccing out your components, I forgot to mention this. If you're doing something for industrial usage or automotive usage, there's certain requirements you may have for temperature or reliability. Since I'm designing something for students, I'm being kind of a little bit I'm caring about what the temperature range is. I don't need it to work in industrial temperatures. It has to work indoors at 70 degrees Fahrenheit. So
it's a consideration.
It's a consideration. However, you may be forced to pick different components or suppliers based on the temperature rating. I'll pay a little bit more for industrial, but I don't need it.
Okay.
Okay, so temperature sensors. So there's all sorts of things. Let's go to temperature sensors and let's do that magic where we sort by price.
One of the things I like about the Digi-Key site is when you roll over the little images to the left.
Oh yeah, this is fun. Hey.
For looking at.
Yeah, I do like this.
For looking at packages.
This is new. It tells you, it's it's going to be a SOT 23.
Yeah. Maybe we'll add this to our site.
That is kind of nice. I mean, this is. It is quite new because I don't remember seeing it.
I've lived with you for a while. I'm pretty sure this is new because you're always on this site. And I don't remember seeing these things. It's really fast too. I think they might preload the images.
Yeah. Well, these are really basic. Okay, so we're searching for temperature sensors, and we sort by price backwards, and came up with the LMT88. And so this is an analog temperature sensor, and I can get it for about 20 cents. Thing is, this gives you an analog voltage out, which is all well and good, but having sold thermistors on the in the store, I know that where you don't really need to have an analog temperature, with an analog voltage out. If you don't mind doing some math, you can use a thermistor instead, and then you just pair it with a 1% resistor, and you're going to get pretty much equivalent. I mean, thermistors are quite good. You can get very good range. It's not going to be an all-in-one chip, and it's not going to give you a perfectly, a voltage output that's easy to discern. But this is 20 cents, but let's look up thermistors. Because there's a lot of different ways to do temperature sensing. So there's NTC and PTC. There's ones that are negative and positive. It doesn't matter which one because each one will have a data sheet that tells you what it is. And then let's just sort by price here. And you will see that you can get a thermistor for 3 cents. So that's a pretty good deal, and it's about 3%. Again, I don't need to have something that's 0.1% accurate. I just need something that's pretty good. So and having used thermistors like this as wires, I know that you get within a degree or two, and they're perfectly good. So rather than blowing 20 cents of my budget, I'm going to only go with 3 cents of my budget. I need a 1K resistor, a single 10K resistor. But I'm going to use a 10K resistor for pull-ups and whatever on my design, so it's not a big deal. So let's add a thermistor for 3 cents. Wow, what a bargain. So we just add temperature sensing for 3 cents. It's so worth it. And this is another reason why it's good to have a microcontroller that has analog inputs, because it lets me use a thermistor. Some microcontrollers don't have analog, like the ESP8266. It's a really great Wi-Fi chip, but it has one analog input, and it has 1 volt max, and it's kind of nice to have like multiple analog inputs to do all sorts of sensing. So, okay, I got a thermistor. And then that's like the cheapest sensor you can possibly get. And then I was like, okay, well, I want a light sensor because light sensors are very easy to use and are also low cost. So you can use, for example, what we use a lot is like a CDS photocell. So this is a CDS photocell. These are very familiar. We even had a video with Colin. We'll talk about these things. And they're really cheap. I'm trying to think. I don't know if Digi-Key carries them. But basically, you can get them for like 5 cents if you're buying a lot. Like, they're very inexpensive. This is like if you buy one. Let me see if I sort. Yeah, 35 cents. You can get them for much less. You can actually buy them on eBay and stuff. The only problem is that, see how this has a little like X over it? This means it's not RoHS compatible. It's not RoHS compliant. The cadmium cells used to be RoHS. There was an exemption for a few years. That exemption expired recently, like a year or two ago. So CDS photocells are no longer RoHS compliant, which means if I do use this, it will not be able to be sold in Europe because there are RoHS requirements for goods imported into many parts of Europe. That's not something I really want to deal with. Also, this is a through-hole part. I prefer to keep it all surface mount for ease of manufacturing. So even though a photocell is like the cheapest way to go for temperature, the easiest light sensor you can get is not a good option. So instead, I'm going to look up light sensor. How are you doing on time?
You're at the hour mark. You're doing good.
Okay, well, I'll finish up in half an hour. Okay, so there's a whole bunch of different optical sensors. And, you can get, all in one. We have like light sensors that are like the TSL 2561. These are lux sensors, and they're like super fancy, and they're I2C, and they give you like precision lux output. That's not what I need. I need something really cheap. So actually a photodiode or a phototransistor, again, I've got analog digital inputs inside, so I can use a very low cost light sensor. So let's go with a photodiode. Phototransistors, photodiodes are very inexpensive. And let's sort by price. So these are all IR sensors, which is actually something I thought about. I thought of having an IR detector so you can use a remote control, but I was like not sure how many people had a remote control. But you can add a photodiode that's IR sensitive for about 8 cents. But these are all IR LEDs. So I'm actually going to go back and go to phototransistors because that's where I want to be. I think, yeah. So let me try here, and I can also let me go by. So the wavelength for the IR ones is about 940, and I want mine to be. Are these all? Maybe I'm a little confused. Let's see if I can. Okay, there's some phototransistors. You can get them for like 8 cents. There's a couple here. Phototransistors. I think that, let me look under, sometimes you have to kind of pick around which category you want to be in. Let's look at ambient light sensors. I'm trying to remember where I found this sensor that I found. No. It was under phototransistors.
This is most of engineering, folks.
Yeah, this is most of it. It's like you have to figure out what, because I think it was under phototransistors, and then I definitely want surface mount only. So let's pick that.
Narrowing it down.
Yeah, you got to narrow it down, and then you can. And then I only want it to be on the reel because I'm only buying like large quantities for quote. Oh, here it is. So now it shows up. So now I got rid of the riffraff. You can decide what wavelength. So the IR LEDs are the 900. So I'm going to get rid of the 900 nanometers. That leaves me only 53. Okay, so now we're getting somewhere. Okay, so these are the ones that are the like ambient light sensors, and then I can sort by price because I'm not looking at all the IR LEDs. And there were basically two, but this one was a pretty good bet. This is the ALS PT19, and this one has a 630 nanometer center, which is basically visible light. You can check out the data sheet to make sure that it's, visible light. It says close responsivity to the human eye spectrum, so that's really good. So that's what I want. I want something that when a human looks at it, it's like, oh, it's very similar to what I see. And I wasn't 100% sure, like, is this a good light sensor or not? And so what I did was not only did I buy a couple, but I actually ended up making a breakout board for it. And I sold it in the shop for a bit just to get a sense of, like, did people like this? I just added a pull down resistor and said, like, hey, like, let's just sell this in the store. And, I made this eval board just to try out the little chip sensor. But it was actually received quite well. Like, never heard any customer complaints about it. Saw people using it in projects successfully. So this sensor is like 10 cents, 11 cents.
Okay.
So that's great.
A deal at twice the price.
Yeah, so it's not so bad. Okay. Well, it's about the same price as a CDS cell. And that's the only two sensors that were like, okay, well, these are like absolutely like requirement, to have some sensing. But then I also had, and there were my, when I was looking at my requirements, I was like, well, if I have an Atmega 32U4, one of the things I can do is replicate a lot of Flora projects. And one of the things that I wanted to do is have it act like a keyboard with capacitive touch, so you could do makey like projects with it. And what's really neat is capacitive touch you can do natively on an Arduino with check out this cool dog. Hey, we did a project on doing capacitive touch with Flora. So this project that we did, we had already evaluated, can you do capacitive touch? And it's actually quite easy. You just connect a large pull-up resistor, and you just connect it to something conductive, and you've got capacitive touch. So what's really neat is that capacitive touch is free with chip, because this chip, the processor that I'm using, has that ability. Some processors also have a temperature sensor built in, but make sure you don't have to calibrate it. In this case, I decided I was going with the thermistor. But depending on what you go with, it depends a little bit. Like, some have good precision temperature sensors and some don't. All right, so we got two sensors, and then I also wanted to have a sound sensor because I wanted it to be able to do what the Scratch Pico board does. And the Scratch Pico board has a light sensor, a sound sensor, a button, and a potentiometer. So I really wanted to have a sound sensor. I thought a sound sensor would be good because a lot of the projects that people like the most are sound reactive. A lot of wearable projects, they could take them out to concerts or parties, and like when you sing or you're listening to music, something happens with the lights. And so I wanted a sound sensor. So we sell in the store an Electret microphone, for example. And so I was like, well, this is what I'm familiar with. But one of the issues with Electret microphones is that it's a through-hole part. And as a through-hole part, you still need to have an amplifier chip and all that good stuff, but you have to hand solder. And I decided I didn't want to have hand soldering be part of the requirement for the Circuit Playground First Edition, because our manufacturing line is pick and place. Basically, if you can get a part on a reel, it becomes very inexpensive to manufacture. So anything you can get surface mount is preferable, given if it's the same price as the through-hole version. So if we can get a surface mount Electret mic, Electret mics actually can't be reflowed either; it has to be done after the fact. But if we can get a microphone that can be put on a feeder, then it's a lot less expensive. Do you want to show off what a feeder is?
Yeah, one of the parts of evaluation is, picking your team members. That was on the list of things in the overview.
Yeah.
And which is kind of funny because when we develop hardware, we try to think, okay, are we going to be able to staff up if this is a success? So this is good timing. So recently, a couple new people are learning the pick and place machines, and they're holding reels. And so this is what a reel looks like. These are like superheroes. They just happen to work at Adafruit. So,
but what they're holding is a feeder, and
yeah,
so that's what.
I'll zoom in. This is Vance, and he's about to put a feeder, and this allows you to have reels that.
It basically gets placed by machine.
Yeah, and I'll zoom over to the reels, so you see he's holding one of the reel the things that, the feeders that hold the reels.
These are the feeders that plug in.
And yeah, so if you can get those parts on there.
Electret microphones can't go through a reflow oven, and so it's a separate step, and so you have to consider it. Again, just because a part is low cost when you spec it doesn't mean it's going to be low cost when you consider the complete design.
Yeah, so by the way, these are some of the folks who make the electronics with love.
They're very friendly. They're just looking tough.
That's our vibe.
Okay, so let's go back to the computer, and let's go to.
We're firm but fair.
Okay, so for microphone, because any kind of sound sensor is going to require a microphone. I ended up kind of looking here, and then if you sort by price, what's interesting is, MEMS mics are pretty inexpensive, and there's a lot of them. So even though Electret mics, Electret mics are you can often get them for cheaper long term. Like if you're buying a huge bulk of them, you can get them very cheaply on the market. I was like, well, let's go with a MEMS microphone, and again, let's look only at tape and reel available ones because I only want them available in reel. I don't want it to be PDM. I'd prefer just get an analog one, and then you can just look at the pricing. Basically, it looks like, okay, you can get them for about 35 cents. So it's a little pricey, but not too bad. And it turns out, I actually made a breakout for this as well. So just to get evaluation of this, I made a breakout for the MEMS microphone available at Digi-Key, and I sold this for a while to get a sense of it. And a lot of people are like, well, you really need to have an op amp. Turns out the design I made for the valve board it's okay, but it should be redone at some point where I add an op amp because the voltage output is not very high. Oddly, I don't know why, but they didn't have the range be. It's meant for very close talking. It's not meant for amplifying far away.
Here's a question: do you always have breakouts and other products before you do a platform like Circuit Playground? Do you always do like eval in the field and testing like this before you come up
in
with
this case, I did because I was working with some parts that I'd never worked with before, and the fact that they were so low cost made me a little bit nervous. I was like, well, if this is like a 35-cent microphone, MEMS microphone, is that good or not? And since I was making an eval board anyways, because there was no such eval board available, like you just buy the chips. Most chips don't come with a breakout board. I was like, well, I have to make a breakout board just to get me started with this. I might as well sell it and also see what the feedback is. Okay, so we're not too bad. We're still, even though we added a bunch of sensors, we didn't go too far. So let's insert some rows. We're getting there. We're almost done.
Okay.
So next up, I wanted to add some NeoPixels because people love NeoPixels. And here's the deal. When you buy NeoPixels by the hundreds of thousands, they're about 10 cents each.
Okay. And how many are on?
Well, that's a good question.
Oh, I get this cool thing. Just by the way.
Yeah.
We kind of solved like a documentation challenge for the world. So this is coming out of Fritzing. This is amazing.
Okay.
Okay. Sorry.
Yes.
No. It's a big deal. And
we're going to talk about the.
You want to talk about that later? Okay.
Yeah, when we get to the.
All right. Anyways.
Marketing. Okay, go back to the computer.
Yeah. Well,
yeah, I know. It looks good.
It's a nice graphic.
So they cost about 10 cents each, and let's say I want to put 12 of them on there so it matches the NeoPixel ring. So this is a lovely NeoPixel ring. And oh man, don't tell me my browser crashed.
No problem. Look at this.
Okay.
I got this going on.
Yeah, I know. Okay, my browser was iffy for a second. So we can multiply this times this, and then we can, adapt how many we want to have. Turns out, like, I couldn't end up fitting 12 on the PCB, so it ended up being 10. So NeoPixels adds quite a lot. NeoPixels is, other than the chip, the most expensive subcomponent. But, they're pretty cool. So these are the trade-offs, is it cool enough? Well, I'm getting to $13, but I think this is pretty good. I'm not done. I want to still add a couple more things. Like, for example, I want to add tactile buttons. And I want, fairly large SMT tactile buttons. So SMT tactiles. And again, because it has to be surface mounts, I put SMT in there. Ooh, interesting. Oh, doesn't do plurals. So tactile switches. And you can get ones that like don't have buttons, and like there's these. This is actually these are really common. They're just like the through-hole style. Then there's little skinnier ones. I'll just get whatever I can get on tape and reel. I don't have to worry about contact rating and voltage. I mean, depending if it is switching a lot of current, you might have to care about it. But in my case, I don't. And then let's sort by price. I don't really like these so much. But, like this kind of thing might not be so bad. And, oh, my browser finally crashed. I have too many tabs open. Wait.
And we're back.
My poor browser. Looks like about 11 cents. And I want 2 of them. So, oh man, my computer's dying.
No problem. I'll go to the biggest screen here. No problem. I'm always ready for this to happen.
Yeah, I know.
A lot of engineering is rebooting computers.
It is. Oh, cool. My entire computer crashed. All right, hold on.
That's all good, man.
We're engineering way too hard. Let me end some processes.
All right. Well, while we're waiting, I'm just going to play Pokemon Go over here.
Okay.
So here. Oh, look what I found. Oh, look what I found. Watch out, Ladyada.
Hold on, drop boxes. You know what? It's actually probably
Yeah, all right.
Office. Close the program. Okay. Yeah, it's Firefox. Okay, so back to
you and your open source.
I know.
Use Internet Explorer like a real man. All right, what do you want to do?
Okay, so go back to the computer. So the 2 tactile switches are, I want 2 of them, and they're going to be about 11 cents each. So multiply it out. Okay, good. So we're at $13.50. And so I'm going to use like some switches like this or something. Something surface mount. Some very basic ones. I can get ones that are a little not as tall, like these are super tall. But also it could be the image. Like you can check the data sheet. There's always like versions that are not as tall. But I don't like these as much. These are like kind of flat. But you can, there are all sorts of tactile switches available. And then I also wanted to add a slide switch, if possible. So I actually don't think the slide switch I used is going to be here. Oh, no, okay, this is pretty close. So you can get a slide switch, and I was like not 100% sure about this. I was like, well, you know what, they're kind of fun to have a switch because you want to, talk about on high and low voltages. So a switch is, let's see if I can, again, pick out ones that are tape and reel. And then these are all surface mount because they're tape and reel. Looks like about like 25 cents. Again, sometimes switches you can get them for less. Looks like I can get pricing here like 22 cents, 20 cents. It's not so bad. So
not too shabby.
Not too shabby. I think it's worth it. I mean, this is, these are all trade-offs. Okay, we're getting at $15, so we're getting pretty close. I mean, we're not doing too bad here. And then we're basically at the last thing that I wanted, which was a buzzer. I wanted a sound output. And the reason I wanted a sound output is I liked having the LEDs, but a lot of beginner projects have like I wanted to have a way for the board to like be able to notify you of things. And I thought a buzzer was really nice because you can do also like sound effects. And like I'm not sure exactly the full reason because like no other boards that I looked at had a speaker on them. But I kind of fell in love with the idea that you could have sound input and sound output, just like you had light input and light output. So I decided to go with adding a buzzer. So a piezo is actually inexpensive, but again, you cannot pick and place them. So I wonder if it's under piezo buzzers. Vendors? Yeah. So like these little piezos, they can make noises and stuff because they're little piezo crystals. And they're not too expensive. So like one of the ones I use is like the PS12. Sorry, PS12 piezo. See if I can find the part number that I like using. I think it's under buzzers. Yeah. So this is like the piezo I like to use the most. It's a 3-volt piezo. You don't need a driver for it. It's AC. The problem is it's through hole. And all piezos are through hole. So even if it's not that expensive, and they're like 30 cents, they are through hole, and so you can't process them the same way, which is, again, a trade-off. I wanted to keep everything surface mount. I was actually still thinking like, okay, well, it's worth it to like hand solder it if I couldn't get a buzzer for a good price. And I ended up finding a vendor that could get me a buzzer for a reasonable price. Well, let's see if there's something similar here. So buzzer, and then again, see if I can get it on tape and reel, which will make sure it's a surface mount part. And then you sort by price. And you can basically get these like surface mount magnetic buzzers, and they're actually a little bit pricey. They're about $1. So like a part like this, it's a surface mount, and it's actually a little speaker coil inside. Trade off, it's $1. So I was like, not so sure, but let's put it down, and then it really is quite a bit of budget. But if I have space for it, I'd like to keep it. Would like to keep, if possible. And let's give myself some more room. So that's all of the sensors that I kind of decided. And I really wanted to have a slide potentiometer, but it turned out that it would either not fit, or it was, if you get a surface mount potentiometer. So what I really like is the style that is the these style, the breadboard trim pots. But the problem is that I'm almost positive these can't go through a reflow oven, even though they're very inexpensive and they're kind of nice. So I said, okay, well, can I get, an SMT potentiometer, like a rotary potentiometer that was surface mount that came on like a tape and reel, for example? And the answer was like, no. There was only like one part that came up, and it's like kind of like this weird part. You can get rotary encoders, which was like kind of neat, but I really wanted a potentiometer in particular because rotary encoders are more expensive. But unfortunately, a potentiometer, they're all through hole. You can get a trimmer pot, which is surface mount, but these are very small. Like this is like 3 millimeters by 3 millimeters, so you wouldn't be able to turn it by hand. And that was kind of a killer for me. I was like, well, I want a potentiometer because I like the idea of having something that, you can twist, but couldn't really do it if it was like, well, you need to include a screwdriver. So instead I was like, well, you know what? How about we go with a different sensor instead? And this is where I was like, well, the only other sensor that was in a lot of the boards that we researched that I kind of liked was having an accelerometer. So an accelerometer is a sensor that can detect gravity and also motion. And so you can use it to do tilt projects, and you can also use it to do like physics experiments. And motion, like when you tap it, it can detect it. And so I was like, okay, well, accelerometer would let me add a lot of cool sensing projects that maybe it would be worth it to give up a potentiometer for, and then maybe in a future version I would re-add it. So accelerometers, you can search for accelerometers. And luckily, thanks to like cell phones and gaming platforms and all that good stuff, accelerometers have gone from $20 to very inexpensive. So you can get an accelerometer for very, very cheap. Let's again search for tape and reel ones. I want ones that have triple axis, so X, Y, and Z, because that way it can do full motion. I'm probably going to want to go digital, but I'm not going to select that yet. And then you can sort by price. And what's interesting is like accelerometers are really inexpensive. You can get accelerometer for 50 cents. And you get a full triple axis 8G, and this is from ST Micro. This one does I2C and SPI, so it's like you even have a choice of how you want to do it, up to 400 hertz. And SMT runs on 3.3 volts, so this is kind of sweet. So let's, I didn't end up picking this exact one, but basically the idea is that you can get them for 50 cents each. Accelerometer, can't spell it, but we'll add it to the bill of materials. So what's neat is actually accelerometer 50 cents is even like half the price of a buzzer. So it's like if I want to have a buzzer, I'm going to have to really think about like, is this giving me a lot of value? The good news is that we're actually well within our budgetary requirements so far. There's still a few components that we're missing. Like I do need a crystal for the microcontroller, and those cost about 20 cents. You know, I need a reset button, which is basically another small tactile, and that's 10 cents. So actually we're getting extremely close. I think, and then I wanted to have a power supply. So we need a little chip that can do the power regulation. I happen to have some chips that I really like. So the AP2112 is one that I buy a lot of these, and they're about 10 cents. So I have this stocked, which is one of the reasons I kept it. So power supply is going to be about 10 cents. And then I also wanted, one of my requirements was, my requirement stock is, I wanted it to be portable, have battery power. Yeah. And I didn't want it to use a requirement for LiPo. So what I thought was like, okay, well, what we did with the Flora is I ended up having this AAA battery holder. It's about the same size as a LiPo, but you can just use AAA batteries. And all it requires is a JST connector. And then if people want to use LiPoly batteries, we have these LiPoly batteries with the same, let me search for, you can use a LiPoly battery if you want, has the same connector, and since it's about the same voltage, you can use either LiPo and then charge it, or you can use that AAA battery holder. So all you need if you're going to use, if we're going to have the this battery holder be an option, is a JST connector. And that basically solves my, how do I make it sure it's portable. So 2pH JST is it pH 2 or 2pH? And this is sort of a standard connector that people, like the maker community's kind of decided, like, okay, a JST connector is sort of standard, all the batteries are going to use it. Finding connectors is a challenge, so if you can use something that's standard, that's good. I want 2 positions. Oh, this is the, right, that's the housings. What I wanted is the other, that's the input side. I wanted rectangular connectors, headers. No, hold on. Let me back up here. Right, it was the headers male pin. 2pH tape and reel. And then, you can have either like a poking up style or side style. Sorry, this is poking up style, this is a side style. And, sorry, this one. Yeah, so this one is like it plugs in from the side. And these are about 27 cents each. I can get them for about 20 cents, so that's good. I'll put that down. 2pH, 20 cents. Okay. So wait, did this even update? Oh, sorry. This needs to go down to 19. Watch out. All right. 1987. So I have matched my bill of material requirements.
Ooh, with a little bit of cushion.
A little bit. Look again. You go back and manipulate some of these. Something I can decide. Some, of course, always give yourself a little bit more cushion, if necessary. There might be some parts here that I can negotiate with and say, hey, I want to, I'm going to buy a lot of these. Can you give me a better price? Maybe like. I can find alternatives as I do this. Again, like for example, the buzzer. If I can't find an alternative that's less expensive than $1, I can possibly do a through-hole version, because I can get the through-hole version of a piezo for 33 cents and be like, okay, well maybe the assembly cost. But remember, you do have to have assembly. There's a couple more costs here that are not included.
Yeah, sure.
So I want to make sure that's clear. So not like you're done. So assembly cost, you're going to have to quote how much it costs. That's something that you'll do later on, but you might want to talk to other people who've done assembly to get an idea, because it isn't just per piece. There's a lot of parts to
testers and more.
Yeah, there's a lot of parts of like how long it takes to test, how long it takes to manufacture, how much packaging you want to do. So I want to say it's about $2 for assembly cost. That's something you have to think about. Oh, hip chat. And another thing is, packaging. Maybe 50 cents for packaging, depending on what you do. And then what else? There's yield. So yield is when you manufacture, not all of the things that you make are going to work out. So you have to add a little bit more. You have to add a little bit to make up for the fact that you're not going to get 100% of the boards that come out of test to be working. It's common to have like a 95 to like 98%. I'm using parts I'm very familiar with. I think the yield's going to be very, very good. I'm only going to say like 25 cents worth of I'm only going to lose about 1% of value due to yield. And then there's also shipping costs that are not included here. Maybe get free shipping. There's a lot of other costs. Some of these you might be able to negotiate your way out of, but they're still there. So the total bill of material is actually a little bit more expensive. So it actually is up to 27. So this is where you actually have to think like, what am I going to take out? How am I going to get it to that $25 price that I wanted? You can do things like remove some of these parts, get cheaper versions of parts, reduce the cost of your assembly. Maybe you can work with your factory to get that assembly cost down. It's a little tough. We do assembly in-house, so it's like we don't end up paying, we only pay the raw cost of assembly, because we do assembly in Manhattan. Another thing you can do is change your margin. Maybe you're like, you know what, I'm willing to live with a lesser margin. I'm willing to live with a 30%, not 40% margin. So before you know it, it's like, well, you just saved like $4, off your bill. It's equivalent to like saving a couple dollars off because you've just reduced how much you're willing to make. There are all these trade-offs that you got to make, but that's so far. Like we are starting to come together with what we're going to do, and as we work on it, some of these parts may change, but I think this is a good beginning. Yeah,
this is a good part of eval. A lot goes into this. All right, I'm going to speed around some questions because we're at the hour-and-a-half mark.
Yes.
Ready?
Yeah.
Okay. So first up, let's go to the overhead. So you have some of the breadboards that you've developed in the past.
Yeah. Well, actually, some of these are the breadboards for like this is the microphone breadboard.
Okay. So these are the ones. And do you have a breadboard?
Yes.
Okay. So those are breakout boards that fit onto a
breadboard. So you can when you do your when you do prototyping.
Yeah. Did you make a breadboarded like circuit playground with all these breakouts, or are you just advanced enough where you can just mess around in Eagle?
I kind of just put it in Eagle, but that's because I was like, you know what? I'm familiar with all these parts enough because I'd played with them. So I didn't make a physical I didn't make like a circuit playground using parts, but I had made these breadboard parts and used it with an Arduino in general to make sure that they worked.
Okay. Next up here, so when you were selecting the chips, Circuit Playground has options with bootloaders, right?
Yes.
So you can handle a bootloader in a couple different ways. How did you decide on that? specifically.
Yeah, that actually happened. Well, depending on what chip you use, you might be stuck. Like the Nordic only has one UART bootloader. There's an over-the-air bootloader, so those are their two options. With the ESP8266, the bootloader is built into ROM. You're stuck with that. With the Atmega 324, you can use an Arduino-compatible bootloader, or you could possibly use a Masteroid bootloader. As I played with it, I wasn't as happy with that, so I ended up sticking with the Arduino compatibility. But we'll talk about that also more in the prototyping and like field testing.
And next up, so when you design something, you seem to have testers in mind for it. So here's some of the photos of the types of testers that we have. This was asked in advance about like how do you know about the testing procedure when you're evaluating? Does that go in? Is that a consideration when you're evaluating certain parts of a design? Like how are you going to test it?
It isn't part of evaluation for me, but that's because I'm working with parts I already know. But thinking about how you're going to test them is something that you should keep in mind. Think about it. I usually do the tester design a little bit more in prototyping. Once I have the board, my first prototype, once I'm happy with it, then before, of course, I go into manufacture, I'll make sure that as I'm doing it, I'm able to test. Do you know what I mean? Like it's something that you can start doing when you're doing evaluation, but I'm still like not sure what parts I'm going to get. So even though it's in the back of my mind, I don't get to it quite until I'm actually laying out the circuit board. That's where I'm actually like, okay, I have to add test points or make sure that I can program the chip. In this case, if I have a sound sensor, it's like, how do you test a sound sensor? That's actually kind of challenging. You have to have something like make a sound and it can detect if it's heard the sound. Like you have to think about like, well, what am I going to do to make sure that this works?
Okay. All right, and then as far as the timeline for how long it took when you were doing evaluation, what would you say your evaluation period for all of this was when you were designing Circuit Playground?
Like 2 weeks or so, I think. Like really, I mean, not off and on.
So if you were doing a time budget, you'd say like 2 weeks.
It is. Here's the thing. I actually don't. I had a plan of like, well, I kind of wanted it done in the next couple months, but I don't. Since I'm the only engineer on the planet, I don't have like a Gantt chart. If you're working in a company, of course, you will have a runway. You will have a certain amount of time you have until the market is closed. Like if you have to hit Christmas, if you have to hit CES, if you have to hit an event, if you have to hit Maker Faire to get your prototype because you want to show it off, these are things that you have to work back from, but also make sure that you can get the parts that you need to do it. For me, it was kind of like, well, I just want to make sure that it's out before September of 2016 because that's the next beginning of the school year. Yeah, so I was like, oh, I'd like to have it back to school, available by back to school.
Okay. Those are the biggies. So what we're going to do next week is design.
Evaluation. Design.
So we'll talk about design.
Design's good.
Yeah.
Design's when you have to start doing that.
Yeah, design is next week. And we'll be going over when it's time to move forward on the project. So that's when the creative process starts.
Yes.
Spend time drafting your electrical and mechanical designs, selecting components, we did that, laying out and technical specifications. We're pretty far ahead on that. Lay out your PCB. This is going to be fun because you're going to be in the wonderful world of CAD. And
I'm going to show it off. I'm not going to redesign the PCB though.
Yeah, I know. But one of the things that's really cool now is because we have a design in a CAD program, we can now pump it through Fritzing, and regular old folks who don't even know about CAD programs can plug into Circuit Playground.
Yeah.
So that's kind of cool.
Yes, we'll talk about that in marketing and how you get people to use your thing, especially if you're a maker and you're making a dev board. Having a Fritzing part's a valuable part. Maybe we'll demo how to make a Fritzing part. Hey.
Yeah. Found another one.
Maybe I'm the Pokemon.
Yeah.
I'm a pink-haired Ladyada.
Okay,
so that's evaluations. We got pretty good. We hit our requirements under $25. At least 3 sensors, at least 1 RGB LED. Works with Arduino, has USB, can use battery power, has sound in and sound out. Doesn't require a li-poly battery and does not require breadboarding. So that like we've hit our requirements. So we're on track.
All right.
Yes.
We'll see everybody next week. Thanks so much.
Yay. Good night.
Bye-bye.